taking a look at 4.6, where we're being asked to use the method for solving quadratics and giving solutions called completing the square. So prior to this, we've seen that we have the option to get a better pen, of course, so we can write all this out, to factor and use the zero product property, which we saw in the previous section. We've also seen, or we will eventually in time see, the quadratic formula, which again gives us solutions to quadratics. So let's say that if we have an xy plane and we have a quadratic parabola that goes like this, what factoring and the zero product property do, along with the quadratic formula, is tell us where this intersects the line on the x-axis. So in this case, we would have two solutions. We've seen factoring and diamond method and eventually zero product property. Completing the square is another option that we have where there's a little less going on, and it's as if we're trying to eventually create the goal of having a binomial being squared equal to some number. So this is really the goal that we aim for in these types of problems. We'll start small, just solving with square roots, and then eventually build into how we complete the square. So with the example seen here, if each side of the square is x plus 3, what is the goal of the square? Well, we can draw this out. If we have this square, this side's x plus 3, this would be x plus 3, so pretty much x plus 3 being squared. If you use foiling or box method, this gets you x squared plus 6x plus 9. It then asks us, how can you use the pieces to form a square with side lengths x plus 3 without overlapping pieces? This could show that. As we see here, we have a product of x squared. We have 3x, so we have 3 versions of x. 6 more versions of x, and then here we have the product of 1, 1, 1, 1, 1, 1, 1, 1, 1. So as you can see, it's as if this is another way, just by breaking up the square, where we can end up with that same outcome. Because if we combine all of these like terms, we end up back at x squared, which we have 6 versions of x. We have 9 smaller squares seen here. So that's just a visual to help you out as we move through this. As far as completing a perfect square trinomial, this allows us to factor the completed trinomial as the square of the binomial. So a lot of these get wordy, but pretty much for this first example, all we're doing is solving by finding square roots. So the main objective here, in my eyes, is to use the reversed order of operations. And then eventually you want to isolate your variable. I mean, we use order of operations to help solve the variable and isolate it. And from there, that's when we take square roots. As we'll soon see with problems like this first one, we don't necessarily know how to solve for x, and we have an x squared term. We could use factoring or try to use factoring, but there's another way that we'll see just by finding the square roots. So if we go by trying to isolate the variable, we can move 5 to the other side, leaving us with 3x squared equals 15. So we use subtraction here. Here we have 3 to get rid of, so we'll divide here, both sides by 3, leaving us with x squared equals 5. And now we're at the area where, if we look at our goal, we've isolated the variable, we can now take square roots. So if we go with the inverse of a term being squared, taking square roots, we are left with x equals square root of 5. But the main thing that's new here is that we now have 2 solutions with this plus or minus sign in the front. This is saying that we have 2 answers. So I'll highlight on this further. Because if we were to plug this back in, whether it's the positive square root of 5 or the negative square root of 5, both of these would provide logical statements that are true. So that's why we want to say plus or minus. I'll give you a moment to solve the next few. If we solve for b, adding 3 to both sides, x squared equals now 32. X squared when taken further equals 4. So x is now equal to positive negative square root of 4, pretty much plus or minus 2. So notice I still followed through with my order of operations. I use subtraction or addition first, most likely. Then dividing by 8, taking square roots at the end. Take this time now to pause and see what the next two problems are like. Give them a shot, see what's working, see what's not working. If we eventually move the 10 over, we have 7x squared equals 35. X squared equals 5. X is now going to be equal to plus or minus the square root of 5. Kind of going quickly with these. So we have 2x squared. Getting rid of 9 on both sides leaves us with 4. X squared is now equal to 2 because we divided both sides by 2. X is now going to be equal to plus or minus square root of 2. Personally, I would keep the radical. I wouldn't rewrite this to a decimal because then that means that a lot of the terms are going to be left off, and you want to keep all of the terms together. So we'll see what happens in the next video when we're actually being asked to complete the square.